So today we're going to start statistics, our first look at the topic for this year. And to start off with, let's have a look at the actual subject matter of statistics. What's it all about? So some definitions. A datum describes a single quantity or quality of some object or phenomenon. Now in statistics, data, the plural data, are represented by random variables. Now a random variable, remember we looked at those last year, a random variable is simply a function, the value of which will be a real number, and that number is determined by the probability associated with the occurrence of each of its outcomes. Now random variables can either be numeric or categorical. Now random variables are continuous if the range or its output forms an infinite set of real numbers. So in other words, it consists of intervals, whereas they're discrete if the range is countable. So it consists of individual discrete values, and those values can be listed. Statistics is concerned with the techniques for descriptive statistics. Now that's the collection, the presentation, and the summarization of the data. And also inferential statistics. Now that's once you analyze that data that you've collected for the purposes of making decisions in the face of uncertainty. In other words, trying to predict outcomes. So let's have a look at descriptive statistics. So our descriptive statistics, well, they provide simple summaries of the data. So we've gone and collected the data. How we choose to present it, well, it might be visual. So we might put all that data in a table, or it could be a graph or a chart. It might be quantitative. So that's where we use statistical measures. Now for univariate data, so single data, we have our measures of central tendency. Now you'll know those from previous years, mean, median and mode we've looked at so far. And measures of spread, variance, standard deviation, range, interquartile range. Bivariate data, which we'll look at a bit later, is where we look at things like correlation, the line of best fit. So first of all, let's look at visual summaries. So frequency tables, probably the first thing you looked at with statistics. Now both numerical and categorical data can be placed into a frequency table. Now numerical data can then also be put into what we call a cumulative frequency table. So let's do this as an example. We've got a class of 20 students, and those students are surveyed to see how many pets they own, and the results we've got here. Now to place information into our frequency table, a common way of doing that is simply using a tally system. So let's record these. First of all, we'll put a stroke for each piece of data. Now when we reach 5, we usually strike it off to represent this is a group of 5, and we keep doing that until all the data has been recorded. From there we can work out the frequency. We simply add up all the tally marks. So for ours we see we've got 4, 6, 5, 3 and 2. Then we have a total column at the end there. That's a nice way of making sure we have recorded all of the data, and yes, these do add up to 20. All right. Well, another way of representing it is a contingency table. Now, contingency table, sometimes called a two-way table, presents categorical data in terms of frequency. Really useful for solving conditional probability problems. So here's an example of one we've already recorded all the data on eye colour into two different categories, female and male. And so the question we want to know is, well, is being male and having green eyes independent? Or does some relationship between the two exist? So being male increases or decreases your chance of having green eyes. You may recall one way we can work out independence is if the conditional probability of A given B is equal to the probability of A. And that's what I'm going to use here. Now looking at our two-way table, we can see that the probability of male, well, there's 82 males out of 167 people that were surveyed here. So 82 out of 167. That's about 0.4910. Now, what's the probability of male given that they have green eyes. So now I'm only looking at the green column, and there's 35 people in the green column. Of that, 20 are males. So we have a probability of 20 out of 35, and that's 0.5714. Well, that's not the same as the probability of male. So therefore, being male and having green eyes are not independent events. Okay, well, let's now have a look at some common graphs and charts, which you will have seen probably in past years. One very common way of displaying data, and I'm using our example of the number of pets. We could put that information in a line graph. Maybe you'd prefer a column graph. A pie chart or a sector graph is another way of displaying that information. A bar chart. A bar chart's very similar to a column graph. It's just that they're going horizontal instead of vertical. Dot plots, where each dot represents one piece of data, and the dots then look very much like the column graph. Now, a Pareto chart. A Pareto chart's a very special type. It's used to indicate the frequency of defects, so businesses use them. It's a way of working out where to best focus their efforts to reducing the defects that they might be occurring in their production of something. It basically consists of two graphs that are drawn together. You have a frequency histogram, and that histogram is arranged in descending order, and a cumulative frequency polygon. So here's an example. Some business that's making shirts. And there's all potential places that the defect in the shirt could happen. It might be the button, it could be the pocket, it might be the collar, the cuff, the sleeve. And so they've looked at all these defects. There's 59 defective shirts that they had a look at, and you can see the frequency there. Now, they've been arranged in decreasing order. So button had the highest frequency, down to sleeves being the lowest frequency. And next to that, I've created the cumulative frequency by simply adding the frequencies as we go along. So let's have a look at the Pareto chart. You'll see it has two scales. One on the left-hand side, and that is representing frequency. Frequency is the one we're using for our frequency histogram, but we've placed them in descending order. So the columns are getting smaller as we go along. The right-hand side, that scale is for our cumulative frequency, but we're interested in that as a percentage. And it's a polygon, so that's the same as a line graph. And we usually plot these in the middle of the histogram. So when you look at this one, you can see, well, look, if we were to eliminate the defects in just the button and the pockets, and the first two there, you'll actually end up getting rid of 66% of all the defects. So if our shirt maker wanted to try and improve, rather than focusing on all of the defects, just focusing on fixing up the problems with the buttons and the pockets would eliminate 66% of all the defects. Well, let's now have a look at quantitative summaries. So central tendency. So just first of all, we're going to look at two of those ones. The mode. Now the mode is the score, the datum, that occurs most often. Now in our example, the most frequent one was one pet. So most of the people, or the highest frequency was one pet. Now it may not be unique. It may end up being bimodal, or there might be two different scores. They both have the same frequency, which is the greatest. It might be trimodal. There could be three scores that have the greatest frequency. After that, we just usually say, well, it's multimodal. So if you've got more than three scores with the greatest frequency, we say it's multimodal. The median, well, that's the middle score. So how we work it out? Well, if you've got an odd number of scores, it will be the actual middle score when you arrange it in ascending order. Now, if you've got an even number of scores, however, then what you have to do is average the two middle scores. Once again, the data has to be arranged in ascending order. So our example, we had 20 scores. That's an even number. So the median will be the average of the 10th and the 11th scores. That ends up being 1.5 pets. Now, of course, you can't have 1.5 pets. It's just a statistical measure. Measures a spread? Well, the range. Now, the range is simply the difference between the maximum and the minimum score. So categorical data can't have a range. Only numeric data will have a range. So in our example, the highest one was 4 pets and the lowest one was no pets at all. So we have a range of 4 pets. So here's where we start looking at the statistics for this year. So exercise 15A is what we'll start off with.